Hello, this is Jack Anderson, Helen Hu, and Ryan Rentino. We are junior mechanical engineers at Johns Hopkins University, and this is our heat exchanger project for our heat transfer laboratory class. Our design does not follow any of the traditional heat exchange styles like the concentric tubes or plate design. However, it is loosely similar to the shell and tube design found in common heat exchangers. The fluid enters through the higher inlet of the tubing, spiraling downwards, and exits through the lower outlet of the exchanger. As the water moves through the tubing, heat exchanges radially outwards to the surrounding coconut oil, which will melt in turn. The hot water enters the heat exchanger and convects heat to the inner surface of the copper tubing. Next, the heat is convected through the copper to the outer surface of the tubing, and through its contact with the PCM, the heat conducts into the PCM material.
The PCM absorbs heat, which causes the temperature of the PCM to increase radially. Thus, the PCM gradually melts over time. Once the PCM has melted, the liquid PCM flows down to the bottom of the container, and solid PCM takes its place around the tubing. To construct the heat exchanger container, 11-inch by 11-inch, 3/8-inch thick foam board panels were used and sealed with silicone and hot glue. 20 feet of 3/8-inch copper tubing was used, with 20 washers attached to give each coil of tubing enough space. Bulkhead fittings were used to provide a strong seal for the system. Since the tubing came as a roll, we simply vertically stretched the tubing such that the washers could space the coils. The foam board was cut to dimension and then held in place while the hot glue was applied to join the boards together. Finally, silicone was used to make the device waterproof.
The hot water inlet temperature was 40.3 degrees Celsius and the outlet temperature was 32.5 degrees Celsius. The flow rate was 0.5 liters per minute. We did not notice any sources or spots of leakage. The water reached 30 degrees Celsius at roughly the 42-second mark. This is twice as large as our theoretical estimate of approximately 34 seconds. From doing our project, we learned more about creating a heat exchanger and what design elements could help us reach higher efficiency in doing so. In addition, we also learned organizational skills through splitting work up as a team and financial skills through managing our budget in order to purchase items. If we were to redo our project, we would try to incorporate more washers as well as solder the washers in our design to act as fins in order to maximize efficiency. Additionally, another design idea that may have been beneficial would be to create a mesh fencing to weave the wires through with the same goal in mind. This was originally our plan, however, due to the material/budget and time restraints, we were unable to do so in our final heat exchanger.